Welcome to Cruz Learning, where it's just that easy, with your favorite host, Professor Cruz. And today we're going to talk about compound inequalities, the and statement, and the or statement. So let's get started. First of all, we have to make sure that we are familiar and we exactly know what we're talking about when we read an inequality sign. So I wrote already for you what the greater than sign looks like. And if we put a line under it, then it becomes the greater than or equal to sign. So those two signs are the greater than signs. The two signs below are the less than signs. Now, the less than sign, I always remember it because it almost looks like an L. So when I wrote less, notice that I kind of used the actual symbol to write down less. Okay, so the less that sign, it looks like an L. I know that maybe you've heard that it could be Pac-Man eating the bigger number, or it could be an alligator if you're from Florida, right? Eating the bigger number. But when it's about expressions, sometimes that doesn't help you that much. So this hopefully will help you remember what the greater than sign looks like and what the less than sign looks like. And just remember, if you add that line at the bottom, just like if it was an equal sign, then it will be greater than or equal to. So let's go to the first example. Example 1. How can I express that all numbers less than or equal to 4? Well, in intermediate algebra, we're going to use three different ways or three different main ways that we can express this. The first thing is interval notation. All right, through interval notation, if I want to express all numbers that are less than or equal to 4, I'm always going to start imagining that I have a number line and I'm going to move from the left to the right. So I'm going to start with all the negative numbers. So I'm going to start from negative infinity up to 4, okay? Because it says less than or equal to 4, and I'm going to stop. Now notice that I used a parentheses at the beginning. Parentheses means not included. This is very important that you copy this down. Everything I write down, please you write down as well so you have your notes. Not included, and the bracket means included. So this is very, very, very important. The reason why I use a bracket with the 4 is because it says equal to. If it didn't, then I will use a parentheses because it's not included. You're going to notice throughout the entire presentation that I will always write a parentheses with the infinity sign because the infinity sign is not a number, so it cannot be included. The infinity sign is just a symbol that tells you that you keep going forever. All right. So that's how you do it in interval notation. How can I express this as a graph? Well, think about a number line. Well, obviously to the left is negative infinity, all my negative numbers. To the right, all my numbers keep getting bigger, so positive infinity. And 4 is here somewhere. Okay, 4 is here somewhere because 4 is included. One type of graph that you can see is that we actually write down the bracket over there. And we can only care about the numbers that are less than 4. Then those are the numbers that are to the left, right? To the left of 4 in the number line. So that's one way that you can see the number line. Another way you can see the number line, and you're probably familiar with this if you did this in high school, is with a dot, an open dot or a closed dot. Because this is included, this uses a closed dot. Okay, and we're going to assume that 4 is right there in the same place. So this is 4, and it's a closed dot, and we're moving to the left of that dot. So everything that I'm bolding, right, that I'm covering right here, those are all the answers. So set builder notation looks a little bit different, but you need to be familiar with it. Okay, set builder notation looks like this. You're going to talk about x, and we're going to talk about all the set, or the set of all x, such that x is less than or equal to 4, because that's what our problem says. And then we close our braces. So exactly what this means is the set, okay, the set of all x's. This line here means such that, and then we talked about the actual meaning of our expression, such that x is less than, and because we have the line under it, or equal to 4. Okay, so all these ways you could represent the same information. Okay, and different problems are going to ask you in different ways. So let's get comfortable by writing the different ways with two more expressions, shall we? All numbers greater than -3, where if I were to use the interval notation, that will be really easy. That's just starting at -3 and ending at positive infinity, because it's all numbers that are greater than -3. If I note that in a number line, this is negative infinity. There's going to be positive infinity. 3 is here somewhere. You could write 0 if you want to for reference, but you don't have to. And then if you use the parentheses way, right? So this is a parentheses, and I only care about the numbers that are greater than 3. Well, the numbers greater than 3 are to the right of 3. So that's one way of doing it. The other graph that you might be familiar with, okay, again, negative and positive infinity. We have 3 right here. Now, this is greater than. Is not greater than or equal to, is just greater than. So I'm going to have an open circle instead of a closed circle, and I'm going to go to the right, just like I did in the previous one. Okay. The last way that I want you to do or know is set builder notation. So this is all x's, the set of all x's, such that x is greater than -3. And then I close my braces, and that will be the answer. Let's do example 3. All numbers greater than or equal to 5. I encourage you to try it. Maybe you could try it, all right? I'm going to graph this first. I'm going to do this a little bit different because maybe it helps you graph it first, right? 5. Try to get it before me. Am I going to go to the right or to the left of 5? Well, I'm obviously going to go to the right of 5, okay, because this is greater than. And then because it says equal to, I'm going to use a bracket, okay? If I try to use the other graphing method where negative infinity is here and positive infinity is there, then I set 5 over here. And am I going to have an open circle, a closed circle? I like to think that this little line fills in the circle. So if you have that line fills in the circle, that means equal to, it is included. Now let's talk about our interval notation. Interval notation, because 5 is included, I'm going to use my bracket, and I'm going to write down 5, comma, up to positive infinity. Now let me make a note here, and it's very, very important that you write this down and you know the mistake, because this is wrong. I cannot write down positive infinity up to 5 and close it. This is completely wrong. The reason is because we're not reading from left to right in the number line. And everything that we do, when we learn how to write, when we learn how to read, we learn from left to right. So when we get to math, we also want to make it consistent and read all our graphs from left to right so that everybody can clearly understand what we mean. This will make me think that you meant negative infinity up to 5, and it will be marked wrong. If you start at 5 and you go bigger, then you have to start at 5 when you write down. Start at 5 and then go to positive infinity. The set builder notation, hopefully you know how to do that one, is all the x's such that x is greater than or equal to 5, and I close my brace. All right, perfect. So I'm done with the inequalities. Or the introduction. That was more like the introduction to inequalities. So now let's talk about the and statement, because with the and statement, we'll be able to solve inequalities, okay? So let's talk about it. And hopefully this will make sense. And means a compound inequality, and it is interpreted as intersection or an overlap. Now let me show you what I mean by that. If I have x is greater than 7 and x is less than 9, and I try to graph that on a number line, right? So I'm going to have 7 here and 9 here. Obviously 0 is there somewhere. So I care about all the numbers that are greater. Okay, so I'm going to graph this in yellow. And because it's greater, okay, I'm going to use a parentheses. Not a bracket, but a parentheses, and I'm going to move to the right because this is true for all these numbers. All these numbers are greater than 7. Okay. Also, I'm going to come to my graph and I use a different color for illustration purposes. And I'm going to do everything, all right? I'm going to cover everything in my line that it's less than 9. So I go to 9 with a parentheses and I go below 9. As you can see, there is an overlap right here. There is an overlap where both of them go over, right? They intersect. So therefore, my solution, if they ask me for the solution of this problem, will be all the numbers, okay, starting at 7, so greater than 7 and less than 9. 7 and 9 are not included. So 7, the number 7 is not an actual answer for this. Because I start at 7 and I end at 9, you will quickly realize that the less than signs are your best friends. Okay, so if I'm going to do set builder notation, I'm going to write down that this is the set of all x's such that, and then I'm going to write down, I'm going to leave some space, x less than and less than. Right there, that expression, it's one of the best expressions and they will become your best friends because when you have two less than signs, all you got to do is on the left side, write down where you start. On the right side, write down where you end. So you start at 7 and you end at 9. And it's just that easy. Hopefully, this will make more sense as we repeat it. Don't worry if you didn't get it the first time. You could rewind the video or you could watch the next example. So here we go. Again with the and statement. And statement. We're looking for where we overlap. Something that repeats, okay? Something that repeats. That is true for both. Again, we have 7 and we have 9. They're both parentheses, so numbers greater than 7, we're going to go to the right. Also, we care about numbers x is greater than 9, so numbers greater than 9. But this time, I'm going to go to the right again. And when I go to the right again, where do I overlap? I only overlap on the right side after I pass 9. So what is my new solution? My new solution are all the numbers greater than 9, right? All the numbers greater than 9. So if I have interval notation, I start at 9. So I'm going to start at 9. And I'm going to end up at positive infinity because I keep going to the right. If I have set builder notation, all I have to do is write down that this is all the x's such that x is greater than 9. And I close my bracket. Let's do example 3. Are you ready? Because example 3 is where it's at, okay? Example 3 is where it's at, and I hope that you get it. How can I graph this? Now I actually have an expression. X is not by itself. So at this point, I'm going to solve for x, like you know how to do. On the left side, x is not by itself because it's being subtracted by 20. So I'm going to do my inverse operation and add 20 to both sides. This is going to be x is less than positive 4. I bring my and down. Very important that I bring that down. And then negative 16 minus 11. Well, x is minus 16, sorry. So you're going to add 16 to both sides. So you could get x by itself on the right side of the inequality. And you're going to have the x is greater than 5 because 16 minus 11, it gives me 5. Perfect. This looks like example 1 and example 2. So from here, this should be easy. I could graph 4 and 5. I always graph whatever numbers I end up with, right, when I have the inequality. It looks like 4x is less than 4. So if x is on the left side, I can just follow that pointy arrow. That's saying go to the negative side, right? So I'm actually gonna use the circles now. So 4 is not included. I'm gonna move to the left. Here, I made a mistake, and I hope you caught it. I forgot to write down the equal to sign. So you got to write the equal to sign. Okay, so x is greater than or equal to 5, because if not, that completely changes my answer sometimes. And this is going to be greater than 5. So I'm going to go to the right. And I'm going to look for my overlap. But when you look, you see there is a problem. There is no overlap. Okay, there's no overlap. So you know when you're trying to find something and you can't find it, you know what to write. That is a no solution. Just like in the previous section. No solution, which also means does not exist. DNE means that it does not exist. Okay. So that's how you solve that problem, and that will be your answer. Sometimes it will say no solution, sometimes it will say does not exist or D any. All right, here we go. Solve. Now let's solve this. These are compound inequalities. So they're still and statements. They're just written with your best friends. Less than and less than. And that's why I put that, because less than is your BF, not your BFF. That's too much. Let's not push it. All right, just BF. So here we go. This is really easy because when you have less than signs, all you got to do is write down whatever numbers you have in your statement, in your expression. You start at the first number. So I'm going to start at 0 and I'm going to end at 10. Okay, and this is my overlap. I only care about the numbers that are in here. Okay, so that's it. That's the graph. If I wanted to write the solution in interval notation, then these are all the numbers that you start at 0 or greater than 0 and you end at 10. Remember, start, end. Start and end. All right, let's solve this one. Now, x is almost by itself, but not quite, because I'm adding 9. So I'm going to have to subtract 9. But because I have not 3 different parts to this expression, I'm going to have to subtract 9 in every single part. 0 minus 9 is just negative 9, less than or equal to x, because this cancels. And this is less than 1. 10 minus 9 is 1. Now be very careful because you have 2 different signs. One is less than or equal to, and the other one is just less than. But when I'm going to graph this, I'm still going to graph it exactly the same way. I do my graph. I have negative 9 here. I have positive 1 there. And then negative 9 is included. I'm going to start at negative 9. 1 is not included, so I'm going to put a parenthesis, not a bracket. And then everything that it's in between. You start from negative 9, you end up at 1. If I was going to draw this or write it in interval, then I'm going to have the bracket, negative 9, because it's included, comma, 1 with a parenthesis, because parentheses means not included. And that will be my interval. All right, let's solve the next one. What happens when live gives you fractions? Well, when live gives you fractions, you cancel them. That's what you do. And remember, fractions just means division. You cancel things using the opposite. So the opposite is multiplication. So I'm going to multiply every single expression here, every single part of my inequalities problem, compound inequality, by 2. When I do that, 2 times 7 is 14, which is greater than, the 2's cancel here. You don't have to distribute the 2 because the 2's cancel. 4x minus 6, which is greater than or equal to negative 18, because negative 9 times 2 is negative 18. Now, this is like a 2-step problem, because x is not by itself, because it's being multiplied by 4 and subtracted by 6. So my next step is to add 6 on both sides. You always cancel the number without the variable first. And then you're going to get that 14 plus 6 is just 20. Let me write it right here, 20, which is greater than 4x, which is greater than or equal to whatever that is, which is negative 12. All right, 18 minus 6 is 12, and you keep the sign of the negative number, or the higher number, right? And then x is not by itself because it's being multiplied by 4. So I'm going to use my inverse operation and divide by 4. When I do that, this 4 cancels and I get that 5 is greater than x, which is greater than or equal to negative 3, right? Negative 12 divided by 4 is negative 3. Now, I don't like this expression because I don't have less than signs. And my best friend is the less than sign. So what I'm going to do is that I'm going to flip the entire expression. And I can do that. I just have to make sure that the pointy side of my inequality sign is still with negative 3. And the open side, so this is what I mean by the pointy side, right? And the open side is still with 5. I don't want to change the meaning. So I'm going to write down less than or equal to x, which is less than or equal to, because those are my best friends. And then I'm going to flip them. Negative 3 is going to be in the front, and 5 is going to be at the end. Okay, so Negative 2 is going to be in the front. And now I can easily graph this. Okay, I can easily graph this. If I come over here, I start at negative 3. I end up at 5. And then if I graph this, then this is going to be included. And this is, so be very careful because this is not included. All right. So it's very important that you catch your mistake before you finish the problem. Okay. Because that's just less than, and that would be the answer, everything in the side. All right, so that's it. I'm done with the inequalities. I'm done with and. Let's do 3 examples for or the union, and then we are done. So here we go. What happens if we talk about or? Well, sometimes you have inequalities, right? And the inequalities, sometimes life gives you lemons, so you make lemonade. This is not that bad. You just add 4 to both sides because the only difference here is the or statement. That's the only difference. So I still solve this, and I'm going to get that 7 plus 4 is 11, and then I'm going to divide both sides by 6, and I cancel the 6, and I get that x is less than or equal to 11 over 6. I cannot simplify this, so I can stop right there. Okay. But it's important that I bring the or down because this will change it only in one way. So again, I'm going to have to subtract 3 from both sides. And if I do that, I'm going to get that x is greater than or equal to 5. Hopefully you can see that. And now I have my both x's by itself, which means I can graph it. Okay, so let's graph it. If I do this graph, I know that negative infinity is over here and positive infinity is over here. I have 11 over 6, and I know 11 over 6 is less than 5 because 12 over 6 will be 2, so this is just below 2, and just 5 is greater than that, so it's going to be to the right. Okay, so if I try to graph this, I want all the numbers that are greater than or equal to, so I'm going to use a bracket, and then x is greater than or equal to as well, so I'm going to use another bracket, and I'm going to go to the right because I care about the numbers that are greater. Now, there's no overlap here, but or unites everything. It doesn't matter if there's overlap or not. If you have a union, if you have or, then you include everything. So I have 2 parts to this problem. The first part, from left to right, I'm coming from negative infinity, and I'm going to stop at 11 over 6. And 11 over 6 is included, so I'm not going to use a parenthesis. I'm going to use a bracket. And then I'm going to use a U shape. And that shape means union, all right? That's the union shape, okay? So it's telling me that, yes, I care about the left, but I also care about the right. So I have 5 included because I'm going to start at 5 on my right side. And I'm going to keep going all the way to infinity. All right, so that's how you do example 1. Let's do example 2. I encourage you to do it before I do it to see if you could get it right because that will be great. That means that you get it, and once you go to the examples or the homework problems, then you will be able to do them just well. All right, so I'm solving it while I'm talking. I hope that you know what I'm doing. I'm doing inverse operations. But in this inverse operation, something happens. When I have x, and I divide by negative 2, there is one rule that applies here that it's different from equations. And it is that when I divide by a negative number, I need to flip the inequality side. So no negative, people. You got to flip that side. So I divide this and I cancel it. And I have x, but instead of greater, that is going to be less than. I flip that sign. You got to flip that sign if you're negative. And this is going to be negative 2. It looks like x is by itself, so I'm done, and that's one of my answers. Or over here I just subtract 1 from both sides, and I'm gonna get x is less than 2. And once I do that, then I can create my graph, right? I can create my graph. So if I come over here to create the graph, I plug in negative 2, I plug in positive 2, okay, and it looks like let me see, negative 2 is not included. And I only care about the things that are less than negative 2. So I'm going to the left. Positive 2 is not included either. So I only care about all the numbers that are less than negative 2. Okay. Notice that there's an overlap, but I really don't care because this is not an and statement. This is an or statement. So or takes everything. So what will be my solution? Well, there's a solution within another solution. So in reality, my solution is all the numbers coming from negative infinity, okay, up to number 2, positive 2, because all these are included, all to positive 2, and then I close my parentheses. 2 is not included, so then it's just a parentheses. Okay, so that will be the solution if they ask me for a solution. So I hope that that makes sense. The last problem. Are you ready for the last problem? Because here we go. Right here, right now, live. We're going to do the last problem. Well, live for me. I don't know if it's live for you, but you know what I mean. You have x is greater than or equal to. So 42 minus 48, that's going to give you negative 6. And x is already by itself, so that's perfect. Or, and then if I subtract 42 from both sides, all right, I'm going to get that x is less than or equal to 8. And, well, I have that part done. And now I have just graph it. Now, look what happens. This is a very interesting thing that happens. And I hope that you appreciate it, that I'm going over this problem, especially when you're doing the work. If I try to graph this and I have negative 6, I have to go above negative 6, because it's greater than or equal to, so I care about all the numbers that are greater than 6. And if I'm at 8, I need to go less than or equal to, so I'm going to use a bracket, okay? Make sure that my other one looks like a bracket and not like a parentheses. And what happens is I'm covering the entire graph. And remember, the union unites everything. So if they ask me for the solution will be all the way from negative infinity to all the way to positive infinity. And if I were to write down this in set builder notation, I'm going to write that the solution is all the set of x such that x is all real numbers. So all real numbers are a solution to this problem, because if you really think about it, if I think about all the numbers greater than 6, but I also think about all the numbers less than or equal to 8, I'm going to think about all the numbers. So that is everything about compound inequalities and an OR. This was Professor Cruz, and I hope you have a good one, because it's just that easy. Have a great day, guys.